Hello everyone, and welcome back to our channel. Today, we are going to discuss one basic thing which helped a cloud engineer to save cost and scale knowledge about KQL scripting. I'm talking about the orphaned resources, the lost children of your digital architecture. Hey, sit there, silent, consuming power, and draining your treasury, your budget, without serving any purpose. They are the ghosts in the machine. So let's start. Wait. Before we begin this deep dive, understand this. The 4 KQL scripts we are covering today for managed disks, public IPs, network interfaces, and change history are just the tip of the iceberg. I have an entire library of KQL commands. Here's the deal. If you have a specific, unique resource or scenario you are struggling to inventory, a governance challenge, a cost challenge, drop a comment below right now. Tell me exactly which custom KQL script you are looking for, and I will personally help you build it to get the results you need. Let's start first. Let's understand what Azure Resource Graph is. So the Azure Resource Graph is a powerful Azure service designed to provide efficient and high-performance resource exploration and inventory management at scale. It effectively acts as a global search engine and query service for all your resources across multiple subscriptions. Let me show you how we use KQL to hunt down few of the most common ghosts. So the first ghost is Orphaned Azure Managed Disk. This KQL query is designed to find orphaned or unattached Azure managed disks across your Azure environment. It acts like a digital detective to identify disks that are costing you money but aren't currently connected to any virtual machine. So this resources table. What it does. This is the starting point of the query, specifying that we are searching the Azure Resource Graph's main data table. This table contains all resources across all your subscriptions that you have access to. Now see this where type has Microsoft.compute-disks. So what it does, this filters the huge list of all resources down to only those with the type Microsoft.compute-disks. This ensures we are only examining managed disks. Now see the extend disk state. Jarkus toString properties.diskState. So, what it does. This creates a new readable column called disk state. It takes the complex internal property value for the disk state and converts it into a simple string for easier filtering and display. Now we're managed by or disk state unattached. So what it does. This is the crucial logic for finding orphaned disks. It filters the results to include only disks that meet one of two conditions. The disks managed by property is empty, meaning it is not associated with any specific resource like a VM. Now project name, resource group, location, subscription ID, disk state, managed by. So what it does. This selects and displays only the columns we need. It removes all the unnecessary internal data to give us a clean, focused report. Now order by resource group ASC, so what it does. This sorts the final results. Ordering by resource group makes the output tidy and much easier to read and act upon, especially when reviewing a large number of orphaned resources. Hope you understood the first script, which helps you find unattached disks in the subscription. Now let's talk about the second one. This KQL query is designed to find potentially orphaned Azure network interfaces that are not attached to a virtual machine and are not being used by an Azure private endpoint. This helps identify and clean up unused network resources. So again, you have to start with resource table, but need to set where condition with type Microsoft.network.network interfaces, so it will. Filters the vast list of resources to include only those of the type Microsoft network interfaces. Now again, where condition with properties has virtual machine, so what it does. Applies a filter to exclude NICs that have an association with a virtual machine. The has operator checks if the resource's properties do not contain the key for a virtual machine ID. Now same for DD, where properties has private endpoint. So what it does. Applies another exclusion filter to remove NICs used by Azure private endpoints. Private endpoints use NICs but are not attached to a VM, so they would otherwise be flagged as orphaned, even though they are functional. Now, the project and order by statements will remain the same as in our first script, so you don't need any further explanation about this, as we already discussed on the first slide. This Kusto Query Language query is designed to find orphaned or unassociated Azure public IP addresses. These are IP addresses that exist and are incurring cost, but are not currently assigned to any active resource like a virtual machine, load balancer, or gateway again. Resource table will remain same, but our where condition will change, so it will be where type sunsen Microsoft.network publicip addresses. So what it does, filters the results to include only those resources whose type is a public IP address. Microsoft.network publicip addresses. Most users treat Resource Graph as a live inventory resources table. They don't realize it tracks resource configuration changes for the last 14 days in a separate table. This is invaluable for troubleshooting the question, who changed what and when. Use the Special Resource Changes table to see a historical record of updates, creations, and deletions. So what it does, this table being queried. The Resource Changes table is a dedicated ledger within the Azure Resource Graph that tracks all modifications, creates, updates, and deletes to your resources. Now if you can next extend change time, change to date time properties, .change attributes, timestamp with where condition, check where change time ago. 7 days, filters all changes to the last 7 days, so. What it does. This is the primary filter. The AGO7D function represents 7 days prior to the query execution time. The query keeps only the records where the change time is greater than 7 days ago, effectively limiting results to the last 7 days. Next is resource ID, toString, properties.target resource ID, and changed by toString properties, change attributes. Changed by, so. What it does. Displays the identity, user or service principal that initiated the change. Now resource group, what it does. Displays the resource group the affected resource belongs to. And changes properties, changes, what it does. Displays the details of the configuration, change itself the specific properties that were modified. If this video was helpful, please hit that like button, and most importantly, don't forget to subscribe to our channel and turn on notifications. Thanks for watching.